Guys, for today's video, I'm going to be taking Clement Mihailescu's. He's a programming YouTuber. He owns his own business, Algo Expert. But one of his great videos I really liked, especially for practical advice, is if you want to learn a new language, try answering data structure and algorithm programming questions, or basically programming or coding interview questions in a language that you're not familiar with, the one you want to learn. So for me personally, I want to learn C++. Because I'm kind of interested in some future projects, building my own, let's say, or at least working with embedded systems, and getting closer to the metal. And then I also am somewhat interested in competitive programming, and I know that's a very one of the most, I think it's like 65% most used language in competitive programming. So the purpose of this for me is just to develop a new skill set in C++, because I think it'll be a fun and useful language, not only for personal hobbies, but for my career in the future as well. But essentially the advice that Clement gave, like I was mentioning, is questions, programming questions that you solved in another language before. Like for me, for example, it'd be like Python or Java, and you kind of understand the underlying principles and patterns. Just try to solve that in a new language. And once you get stuck at one area, let's say, for example, you don't know how to initialize an array, or you don't know how a language uses strings, or what string methods a language has. That's where you would stop at that point and then look on Google or Stack Overflow and figure out how to properly use that. So I'm just going to, for the next 2 hours, try to answer as much easy or medium questions in C++, and if I ever get stuck at a point where I don't know something in C++, which I had a little tiny experience in, but I'll just search it up. So I've done this with Java before, when I was going from Python to learning Java. That's helped me out a lot, and now I want to further develop C++. So let's get into it. So I'm just going to basically go to Leetcode, go through a couple problems, go C++, and yeah. Don't worry, I'm going to be speeding up a lot of this in the moment work, and you'll just get the highlights. But I'll stop whenever I work on any visualization on my iPad. So if I draw anything to visualize the data structure, or work on the algorithm, or also highlight the blog post I read or the reference material I read. But yeah, for most of it, it's going to be sped up, so any of the boring parts you want to sit through. But if I kind of come up to an insight, we'll slow down, and I'll tell you exactly what I learned in that particular thing about C++. So for example, maybe when I learned C++, learning how to swap different elements in arrays different than in Python or Java. So yeah, let's get into it. So one of the things I want to notice too is how they, in different languages, how you set up classes. So obviously if you do it in Python, it's you initialize, set up classes in different ways, and the syntax is different. So it's always interesting to me to figure out what's different. So you can even see how you do while loops. Like in Python, it's not surrounded in parentheses, but in Java, it is. And then also in C++, I'm going to assume it is too. One interesting thing I noticed so far is that there is this asterisk here. I kind of know what that is working with Go a little bit. I think it's a pointer, but let me just make sure. To an integer, okay, pointer to double, pointer to float. So this pointer is probably just referring to whatever the type is. So for this reverse linked list, we're pointing to a struct list node that has this. And then this same thing has that right here. I wonder if the order matters. So you can see how it's left here and right here. let's try to do that. List node equals. So the actual initialization might be a little bit different too than Java. So I'm going to assume, just based on a Java background, we are able to initialize a temporary node like this. If not, then I'll just have to do some more research. But let's call this prev equals null, while node does not equal null. List node temp equals node.next. So yeah, this selection might be a little bit different, but we'll see. Then we want node.next. Oh, okay, so it is a little bit different. That's interesting. Okay, so it seems I have to use these arrow characters to actually change the nodes themselves. So let's just make sure. So I think I have to use the arrow instead of .next. That's good to know. Okay. Then that would be prev equals node equals temp. Then you return prev. All right, so let's run this and see if it works. Oh, cool. Okay, so basically, this is something I didn't know in C++, but in Java, you would just do something like node.next, and that would like yield like the actual pointer to the next list node. Here in C++, instead of using that dot notation, it seems we're using that skinny arrow notation. So you see right here how you have like the list node val, and then also this list node next. In order to access this next, I have to use this arrow. So that's interesting. I didn't even know that. So yeah, cool. Let's just make sure that passes the results here. Yep, cool. That one's down. Let's go to the next one. All right, so let's go to C++. Oh, vectors. Okay, so I don't know much about vectors. So yeah, I'm a little fuzzy on them. My assumption is that they're an array, maybe similar to like Python list, where they're dynamic arrays, or Java array list. So let's check that out. But let's read the problem. So single number, given a non-empty array of integers nums, every element appears twice except for one. Find the single one. Okay, so yeah, we're essentially just looking for one of them that is there just a single time. Right. Okay. Oh yeah. Okay. So there's two ways to do this, from what I remember. Yeah, there's two ways to do this. So given a non-empty array of integers, every element appears twice, except for one. Find that single number. Follow up. Could you implement a solution with a linear runtime complexity and without extra memory? So that follow-up is interesting because one of the solutions will require extra memory. It will require us to create a hash map, or whatever the hash map equivalent is in C++. So yeah, I can kind of quickly show that on the iPad. So yeah, how you would solve this in a hash map typically. And what a hash map is just like an unordered collection of key value pairs. But the main advantage is with hash maps is that the search, the inserts, and the deletes are all done in constant time, I believe. The only downside is not ordered. Yeah, so search, inserts, and deletes, I believe, are all in constant time. But essentially, again, a hash map is just a key value pair. So for example, for these numbers, let's say we want to keep a count on them. So for 2, we will eventually have 2 count, and for 1, we would have 1 count. And then one way we could do that is like one for loop. We would actually add these keys and count them. So just think about like a count to hash map. And then the second for loop, we would actually iterate over the key and value pairs until like if value equals 1, then we would return that key. So yeah, so that's something that would could be done in linear time because it's just 2 for loops at the same level. But it would also require ON space. So you're basically making it faster by adding additional memory. So this other follow-up is saying, is there a way we could do that without using a hash map essentially, or without using that memory? So one way you could probably do it is, oh, actually there's a third solution. You can also do this by sorting the algorithm, but that would require more time. So usually most sorts happen in O(n) log n time, but that would require no extra space. Actually, let's do because it is higher time complexity, let's do the sorting first, and then we can do the hash map. So first I will do sorting array, vector. That's pretty straightforward. Okay, so I just use that sort function right here. So this first solution, is going to be O(n) log n time. I believe with like, it might not be constant time because I believe when you sort, you also have to use O(n) space. I'm not sure. It could be constant, but don't take my word for it on that single one. And then the second one, we're going to do O(n) time O(n) space. Okay, and this will be the sorting solution. So I'm looking up for loops in C++ just to make sure. Oh, no. Okay, what I wanted to actually do is like I want to check the current array element, the element before it, and the element after it. And if that element is not equal to any of them, that's the single element. Yep. Okay, cool. So that's exactly what I wanted. It is similar to Java, at least the for loop. Actually, yeah, let's make this 1. I'll make that 1. Okay, so again, basically what I'm doing is like we look at this array right here, right? 4, 1, 2, 1, 2. I essentially want to iterate starting here and then check if it's equal to, well, this has to be sorted, I'm sorry. 1, 1, 2, 2, 4. Oh, okay, so this actually is a pretty good edge case. So my thing would not work, at least the way I'm trying to check it. Yeah, this sorted one wouldn't work on the edge cases. So either the first element or the last element, because, for example, yeah, we go to this current element, right? The element before it's 1, the element in front of it is 2. So from that, it equals its less element, so it is not a single number. So we go here, same thing. The right element is equal to 2, so that's not it. And then this last one, it wouldn't equal, but so you see how we're ended there now. Boom. So I guess one thing we could do instead of like yeah, instead of having the edge cases, we could just go for the whole thing. And then we just have like some special places in there where if it is equal to the first element or the last element, only one of them is like checked. So for example, let's look at the details. Is the edge case I consider? Yeah. So now, yeah, if it's just one, then you just return that number. So I know it's not perfect, so yeah, this is the most complicated one. The way to do it, like sort it and do it, like, think about every single ways indexing it, those edge cases. Obviously, it's not the most perfect code, but yeah, the hash map's just easier to add and track those numbers. So yeah, we'll just do this for now, but yeah. Okay, so we're good here. You can see it's not the fastest because it's O n log n time and the memory too that we use to actually sort it. But yeah, let's comment this out and then go towards the other one. But yeah, the cool thing I learned here is how to sort these a vector, and also being cognizant of how to actually create a for loop. It's very similar to Java. I kind of knew this from Java, so I kind of made a guess on dot size. Let's see. Oh yeah, also the operators for like and or they're similar to Java as well, which is kind of cool. Yeah, so those are the big things I learned there. Obviously, we'll probably be using vectors a lot more in other questions. But yeah, let's go to the hash map one. Okay, so yeah, this is a little interesting to me. In Java and Python's a lot different, but yeah, I'm basically iterating over the key value pair. So I'm going to be looking for one of the frequencies that equals 1 and then just return that key. So apparently this is the key, this pointer to first, and then the pointer to second is the value. And basically I think you just have to use the begin and end to traverse through that, which is interesting. So yep, let me just go through here. Oh, so I can actually just iterate this. So instead of doing that like Java-like way, I can just do number counts nums I plus plus. Damn, I made this code really short if that's true. Woo! That's so cool. No, obviously it's not the fastest thing, but that's pretty cool. That's a really short way to actually do that. In Java, it's like 4 more lines. Yeah, so it's definitely a lot I had to learn. This auto thing's interesting. The begin for vectors and maps seems really cool too. These pointers are interesting as well, especially for the key value pairs. For the hash map, this is just like ingenious. I love that. Yeah, so let's go to the next question. Okay, so this binary tree should be easy. Intuitively, I know like what you're supposed to do here. I can kind of draw it, but essentially, yeah, you're supposed to just like at every turn, like left or right, like just switch those left and rights, and at each point, like you switching that left and right is going to get you the result you want. So, for example, this one right here. Let me do a new note. So we have 4, 2, 7, 6, 9. Hey, 1, 3. Okay, so we have that. So at each stage, we're basically just going to like, oops. We're basically just going to switch these two. So imagine, kind of recursively. Oh, don't, okay. Like we take this 7, 6, 9. Hey. And then we're just switching it like that. So at each point, when we get there, we have this level set, right? So at 4, there's nothing to switch, but then we switch 2 and 7, and it's like children. Then when you get to children, like here, 6, 9, and 1, 3, it's going to be 9, 6 instead of these two. And then here, 3, 1. So if we actually draw that out, 4, 7, 2, 9, 6, 3, 1. We will see that that's actually the answer that we're trying to get. So just imagine, like, and you'll be seeing it recursively too, but yeah, basically we're just swapping at each single level. Ah, it is that, okay, yep. Okay, so instead of dots, I have to use arrows. Perfect, okay, let's look. Ooh, nice, cool. Yeah, so the cool thing is, yeah, for these structs, I gotta make really careful to actually use these appropriately. Obviously, some of the Java stuff's sticking a little bit, so yeah, okay, cool. Let's go to the next one. And of course, I'm just doing easy ones, but yeah, I think so far it's a pretty good way to learn about the language, so that's cool. Yeah, so this maximum depth one, you can just easily do something recursive. So we got these pointers again. So those skinny arrows I gotta keep remembering. But okay, so it's just called max. That's cool. Max, depth, root dot left plus max depth root dot, not dot, pointer right. Also, I've done this one before, and I kind of unfairly saw the answer, or like kind of have it structured. Max, no. Oh, that's what it is. I forgot to do the comma. Okay, cool. Yep. But yeah, this is the big thing. Like these skinny arrows are basically in place of like Java's like dot notation. So obviously, if it has like this little asterisk, you have to use those arrows to signify what you're pointing to. Cool to know. Nice. Yeah, let's do that one first. Product accepts self. Yeah, so one of the ways you could easily do this is, oh wait, let's see. Product of array accepts self. Given an integer array nums, return an array answer such that a answer is equal to the product of all the elements of nums except nums I. The product of the prefix is guaranteed to fit into a 32-bit integer number. So yeah, one of the ways is a little bit slower, but it is like you literally just iterate over everything twice, I think. So that's going to be in n squared time. It's not the most efficient. One way you could do it is by actually like using two for loops. And it's not as intuitive at first, but then you realize it's actually pretty helpful. Okay, yep, you're timesing both because, yeah, wait. Okay, so I think I have it. Let's try to visualize that. Sorry, this was a little confusing. Okay, let's just move down. We'll do green this time. So the same thing. 1, 2, 3, 4. Okay, so for this one, with our we're going to have a corresponding output array. So let's say we have our product equals 1, which is an int. We're going to want to times that by everything. So the thing is, with this problem, product array except itself, you want to add everything to the right. So how do you do that? Well, you make sure that you include the current product and then times it after, right? So you're basically saying, hey, we're going to shift this to the right. What does that mean? So for this first one, let's go this first for loop, right? The first element is this, right? So we're not going to times that first. We're actually going to put this int product right here. Okay, so and then you have 1 times 1, right? Okay, so that's going to be the next one as well. Then it'll be 1 times 2. So 1 times 2 will be right here. And then it's going to be 2 times 3, 6 is going to be right here. So on the second for loop where you go in reverse, you're actually going to do the output times the product. So in that case, we also reset it to 1, right? So 6 times 1 equals 6. And then we times it by nums j, which is in this case 4. So product equals 4 now. So then we have the next object, the list right here, which is 3. So, oh, actually, no, right here. So 2. So 2 times 4 is going to be 8. So 2 times 4, and then 4 times 3 is going to be 12. And then on this next loop, you're going to have output j, which is at 1 now, which equals 1. So 1 times 12 equals 12. And then finally, you're going to have 12 times that's 2 right here. So that's going to equal 24 for your product one. And that's going to be 24 times 1. So that's how you get the product of the array except self. It's going to be an on time and o1 space. I mean, of course, you're creating the output array, but for the most intents purposes, you're just using 2 for loops and some clever indexing. So yeah, sorry that was confusing at first, but it kind of makes sense now using 2 for loops, and then the way you're iterating it, you're basically shifting the multiplication with product and then attaching it to an output array. So once you go left to right, you're excluding one array element, and then reverse right to left, you're basically multiplying everything and essentially getting the product, except at every point without that element's value. So, yep, next one. All right, so valid parentheses. This is also like once you understand the pattern, it actually becomes pretty easy. So the pattern that you'll learn is like a stack. So again, I kind of show you this on the screen. So basically, a stack is just a data structure in the first in, first out order. So basically, whatever has come in latest is going to be removed first, and the thing at the bottom is going to be removed last. So imagine it like a pile right here. Let's say that you include like one dish at the bottom. Okay. If you were to remove it, that would be the first one out. But let's say you add another dish, right? So then this is going to be removed next. Then let's say you add another one, and then finally another one. So this first one right here is going to be removed first, then the next one, then the next most one, and then finally whatever's at the bottom is removed last. So why is this a useful data structure? This is a useful data structure because it can help you with ordering and like parsing information. So in this case, you want to make sure something is valid. So for example, you might use a stack like this. Let's say you have an open parentheses. You keep it in a stack because you want to make sure that there's a corresponding closing parentheses. So let's say you put in that opening parentheses right here on the first input. If you have a closing parentheses, then you could easily pop up this item right here because they match. Let's look at something that doesn't match, right? So same stack, but you have this closing bracket, right? These don't equal. Yeah, these don't equal. So you would know for sure that this is not a valid input, right? Let's also look for something like this. Example number 5. This is going to be a good one, right? So first you have a curly open brace. Then you have a square opening brace. Okay, so you can see how that square is the most recent. And the next part of your string, you have a closing brace. So if you correspond these are corresponding ones. So this could be removed. When that is removed, the most recent one's going to be this opening brace. On the next character, you're going to have that closing brace. These are corresponding, and you would just use a hash map to like correspond those, but then this could be removed. And then how you check the logical condition is at the end of it, if your stack is empty, then it is a valid string. If it is not empty, then you either have a bunch of opening braces that never got closed, or yeah, you basically just don't have that. Because if they were all matched, then they would be removed. So that would go right there. A second one would go there, and like so forth. So stacks again are just good for like kind of these parsing of like characters and strings. So very useful data structure. Let's see how to initialize it in C++. Oh, sorry, guys. I was mistaken. I mistakenly called it first in first out as last in first out. So LIFO. So remember that last plate on the bottom gets returned or removed from the stack last. So apologies. Stacks are implemented as container adapters, which are classes used to encapsulate an object of a specific container class. So for example, think about like stack of ints, a stack of chars, stuff like that. Providing a specific set of member functions to access its elements. Elements are pushed or popped from the back of the specific container, which is also known as the top of the stack. So you push or put a plate on top of the stack, and then you pop or remove that top plate from the stack. Push back, pop back, size back, and empty. Size is going to be very useful too. Okay, let's go. And the Q is the FIFO version. Okay, so it looks like you just easy initialize it like that. Boom. Okay, so my explanation here is if this stack is empty and, well, not empty, sorry. If this character, let's say it's an opening one, it's not found in the keys, then you want to add it, right? Because it's an opening character. Else, it's a closing character. If the stack is empty, then you want to return false because there are no corresponding opening ones, so it's an invalid string. And now this else is going to be like, okay, now you have a non-empty stack, and now you got to make sure that you have the most recent or the top of the stack, that character be an opening parentheses, bracket, or curly brace, depending on what this current character is. So that's why the map or the hash map is important, is because for this closing one, we can see if the key is equal to the top of the stack. If so, you can pop up the top of the stack. If not, then you return false. So if you don't find this key there, this means you have an opening one, so you want to add it to the stack. That makes sense to me. And then if it's not, so if it is found there, char pairs, then the stack is empty, you want to return false. If the stack is non-empty, then you want to check the top of the stack is equal to chars.pop the corresponding character. So the chars pair at this closing one. So if it's a closing one, you find the opening one. So you just want to make sure the opening one is equal to this corresponding char. So that should pop it out. And if that's not the case, then you just return false. Oh my freaking god. So sorry guys, I am silly. I keep, again, with just misnaming stuff. That's my apology. Oh my god. Oh, see, that's why you gotta read carefully. That's why you gotta name carefully. This is the type of stuff that's gonna like bite you in the butt on your program interviews. So just make sure like when you like name something to like just double check every place, because you can see that one error. It wasn't necessarily in the logic in the middle. It was me actually the return statement. It was always gonna return false because it was trying to see if the string was empty when we should be checking if the stack was empty. So good to know, but yeah. All right, let's. Okay, so I'm basically kind of like show you like what's gonna happen. Okay, so we'll just do this in green. So again, so you have this 3, 2, 0, 4. Oh, -4 here. That points back to 2. So you're basically just trying to see if there's a cycle. So this is one of the approaches that you can do with arrays or linked lists, but it's called the 2-pointer or fast-low pointers. So you're basically just using 2 pointers to see if they ever meet. So in a cycle, they'll meet. If not, if it's not a cycle, then one of them is going to hit null first. So we'll just do the blue arrow down as the fast pointer, and the slow pointer as the slow pointer as yellow. Okay, so if we have a fast and slow pointer, they both start relatively, I think, at the same place. Yeah, so let's see, we have our slow pointer right here, our fast pointer here. So the fast pointer is going to move by 2, and the slow pointer moves by 1. So that fast pointer moves to 0, that slow pointer moves to 1. Let me just erase this stuff too. Okay, on the next iteration, the slow pointer slow pointer moves to that one, and the fast pointer actually moves back to 2. So it goes from here. It goes from 0 done to 2. So now we have this. So then on the third iteration, that slow pointer is going to move to -4, and the fast pointer is going to meet that slow pointer at -4. So that's how we are able to tell if we have a cycle and a linked list, because it never ends. There's no nulls. And yeah, this is just one clever technique. So this is one of the strategies that you're going to use in your arsenal. Fast, slow pointers, it's helpful, or 2 pointers, helpful in arrays, helpful in linked lists. But yeah, quick way. And that's how we're going to solve it. So let's get right to it. That's good. So slow and fast up next. So I don't even need this null, do I? That's interesting. According to the submission. So maybe I don't even need this. Interesting. Okay. So what am I doing wrong here? Fast, slow, fast. Oh, okay. So it's just the terms of fast. Okay, so how does he deal with this one again? Oh, yeah, yep, okay, that makes sense. So you're just going to do the next one. Okay, so I can set them at the start. I can just do these next pointers first. All right. That makes sense. Okay, I was wondering how you would do the edge case to, consider. Okay, cool, nice. Well, that's all of it. Thank you guys so much for watching here. Big things I learned are like, yeah, you can definitely learn a lot in terms of like language specifics. I learned definitely a lot more about vectors, hash maps, stacks. Also personally with my own coding, being able to just double check your work. So yeah, it's a great way for if you have 2 hours want to learn a new language, definitely a great thing to do. And yeah, thank you guys for watching this video. And it's going to be edited down for you to kind of remove the boring parts. But yeah, thank you again, and check you out in the next video. Thanks.